Okay, so the first question here, write a rational function that has the following characteristic. The x-intercept are x equals -1, x equals 0. The vertical asymptotes are x equals 1 and x equals -3, and there's a horizontal asymptote of y equals -2. You don't have to provide a sketch. So always try to do this in function notation. Let f of x be the function such that f of x is p of x over q of x, and q of x cannot equal to 0. So what does what do the x-intercepts, in this case there are two of them, what do they give us information of? P of x or q of x? P of x, right? So since the x-intercepts are x equals -1 and x equals 0, P of x has x plus 1 and x as factors. Okay, so if you don't see any explicit instructions, I want you to use the lowest degree for the factors, or the lowest degree, overall degree for P of x and Q of x. Okay. Now, so we're done with the x-intercepts, and now what about the vertical asymptote? What information do the vertical asymptotes give us? P of x or Q of x? Vertical asymptote is associated with Q of x, right? The denominator. So since the VAs are x equals 1 and x equals -3, Q of x has x minus 1 and x plus 3 as factors. That's it, right? So f of x equals x plus 1 times x over x minus 1, x plus 3, right? And there's always a leading coefficient that you have to determine. And the leading coefficient, can it be 0? The leading coefficient cannot be 0, right? If the leading coefficient a is 0, f of x equals 0, right? It would not be a rational function. How do we determine the value of a? In the absence of a point other than x-intercepts, you use the horizontal asymptote that's given to you, right? So since, okay, so do we need to adjust the degree of any of these factors? No, right? You can say since the HA is y equals -2 and does not equal 0, right? P of x and Q of x have the same degree. So we're good, right? Degree of 2 for P of x and Q of x. Also, since HA is y equals -2, using the definition of horizontal asymptote, we have that the limit of f of x equals -2 as x approaches infinity. Okay. In particular, equals -2. So how do we manipulate this expression? You common factor out the largest degree of x in each of these factors, right? So the left-hand side becomes, so common factoring out x gives us x times 1 plus 1 over x, right? For this. And then this one, same thing, x times 1 minus 1 over x. This is x times 1 plus 3 over x. So we have x times x is going to be x squared. 1 plus 1 over x. And the denominator is x times x is x squared. 1 minus 1 over x times 1 plus 3 over x. Okay, so x squared cancel out x squared. We get, so this equals -2. So what's the next step in dealing with this this limit? Yeah, so you can quote unquote substitute a really large value of x into 1 over x, right? So that, let's say 1,000,000. 1 over 1,000,000 is really close to 0. So this is where we can do quote unquote substitution. And if you do that, do you keep the limit notation or you drop it? You drop it, okay? So it becomes a times 1 plus 0 over 1 minus 0, 1 plus 0 equals -2. Okay, so it is important that you write these 0, because these will indicate that you are doing substitution. Okay. Now, so what is a? So that means a equals -2. Thus, the function f of x equals -2 x plus 1 times x over x minus 1 x plus 3. And x cannot equal to -3 and 1. Always put down restriction for rational function. Yep.
And like the degrees for both of them are the same. If you divide them, you can both by each other. So like a divided by 1.
You just have to explain it in full, right? If you don't want to do this limit thing, you just have to explain it in full. I take that. Okay, how do we mark this? Each of these correct factor is 1, 1, 1, right? With the reasoning, and determining the value of a is 2. So it's out of 6. Out of 6. So same thing. I'm gonna let g of x be p of x over q of x, but q of x cannot be 0. So let g of x be that function, right? So now you have a graph, so you have to read off the graph information such as the x-intercepts. What are the x-intercepts here? X equals -3. And x equals 1. When you have the graph, right, you can tell the behavior of these x-intercepts. So what do I mean by the behavior of the x-intercept? Whether the graph crosses or bounces at the x-intercept, right? So in this case, when x equals -3, the graph crosses. So what does that infer? So this is an odd exponent, right? Well, not the exponent, the multiplicity, right? What about at x equals 1? It also crosses, so this is also odd. Okay, the multiplicity, not the exponent. Meaning the factor would have associated with these will have odd exponents. So P of X has X plus 3 and X minus 1, right? As factors. So vertical asymptotes can also be clearly seen on the graph, right? If they're not clear, it will be given to you as written information. So from left to right, we have X equals -2 as one of the vertical asymptote. X equals 0 is another one. And X equals 3. And with this, with respect to the vertical asymptote, we also have the behavior of the graph around the vertical asymptote also tells us about the multiplicity of that factor. With respect to -2, the graph grows in opposite or same direction? Same direction, right? Going down, same direction. So what should the multiplicity associated with this be? Odd or even? Even. At X equals 0, the graph grows in opposite direction, so this should be odd. And with respect to X equals 3, the graph grows in opposite direction, so we should also have an odd multiplicity. So Q of X has X plus 2, X, and X minus 3 as factors. Now, the function is not defined at X equals -1 and X equals -1. So there are only two types of undefined, right? We have vertical asymptotes, and we also have point discontinuity or holes, right? So when X equals -1, Y is defined, right? Well, no, it's not Y. It does seem like it is part of the graph, right? But it tells you explicitly that it's not a point, it's not defined. So this is a hole. So how does a hole manifest in this equation? Yeah. Yeah. So the 0 associated with that X is common. It's a common factor, right? In both P of X and Q of X. So since G of X is not defined at X equals -1, X plus 1 is the common factor in P of X and Q of X. Okay. So G of X is, I have X plus 3, X minus 1, X plus 1 over X plus 2, X, X minus 3, X plus 1, right? And I always have the unknown leading coefficient that I have to determine. So now, because of these odd and even multiplicities, we have to put down the exponents for each of these. We have to determine, right? So bear in mind, always use the lowest degree. Now, with respect to this, so the smallest positive odd number is what? 1, right? 1. 1. Okay. What about x plus 2? X plus 2 has to be even. The smallest even positive number is 2. So I'm going to use 2 for that. So what is the overall degree for P of x, Q of x? 5, right? 2, 3, 4, and 5. Okay. So now, how does that help us determine the degree of each of these? There is an HA, correct? So if there's an HA where y is not 0, what does it tell us about the degree of P of x and Q of x? It's the same, right? They have to have the same degree. So now let's look at this. X minus 1 is odd. This one, we keep it as odd, as 1 and 1. So the smallest is 1, 1. So what does this need to be? This also has to be odd. What's this? Can this be 1? If this is 1, the overall degree will be 3, right? So it would not give you a horizontal asymptote y equals 2. So one of these would have to have a degree of 3, right? So which one? X plus 3 or x minus 1? If you look at the graph, right, which one should have a higher degree? X plus 3 or x minus 1? I would say x minus 1, right? Because it does that. Remember from your polynomial, right? So I will make this 3. Now the degrees tally, right? So you can say since the HA is y equals to 2, the degree of P of x must equal the degree of Q of x, right? So now these are good. The degrees match up now. So how do we determine the value of A? You can use the equation of the horizontal asymptote. Same thing. Just same as the first question. Since the HA is y equals 2, right? The limit of g of x equals 2. In particular, it's all about the transitioning, right? So in particular, A so what do we do with the left-hand side? Common factor out x. So we have A here. So common factoring out x from x plus 3 gives me x times 1 plus 3 over x. This is this. Okay. This, I common factor out x is going to give me x cubed, right? And then I have 1 minus 1 over x cubed. This thing, common factoring out x gives me x times 1 plus 1 over x. The whole thing divided by common factoring out x gives me x squared times 1 plus 2 over x squared. This x stays the same. This one, common factoring out x gives me x times 1 minus 3 over x. Same thing here, x times 1 plus 1 over x. Okay, so now I can, x times x cubed times x is x to the power 5, x squared times x times x times x is x to the power 5. So these x's cancel out. Don't forget, this is an equation equals to 2. So now I can drop the limit notation by doing a substitution. Think of x as a huge number, let's say a million. So the left-hand side becomes no more limit notation. I have A times 1 plus 0 times 1 minus 0 times 1 plus 0 divided by 1 plus 0, 1 minus 0, and 1 plus 0 equals 2. So A is 2. Okay. Thus, g of x equals 2 times x plus 3, x minus 1 cubed, x plus 1, the whole thing divided by x plus 2 squared, x minus 3, x plus 1. Oh, okay, so don't forget the restrictions. What are the restrictions? X cannot equal to -2, -1, 0, and 3. As required. Okay, so how do we give marks to this?
Yeah, x plus 1 and x plus 1 can be cancelled out.
I know, no. So you have to write it in its entirety. This is not the same as this, right? Does this have a hole at x equals -1? This does not have a hole. This has a hole, even though the graph looks the same everywhere else, right? You have to include these. Otherwise, it's a different function. Okay, good question, though. Now, let's do some mark allocation.
I have a question.
Yeah.
What if you have a function where the restriction is like an imaginary number? Then what do you do?
The restriction is an imaginary number?
Let's say,
Yeah.
No, on the bottom you have, let's say, x squared plus 2 or something.
Yeah.
Well, how would you write the restriction?
No, there's no restriction associated with that. There's no restriction associated with that factor. Meaning, yeah, there's no associate. Yeah. So we'll be looking at that in the next question.
That's I just thought.
Yeah. So there's no restriction. Okay. So how would you give marks to this?
You should give the area. Yeah. Great idea.
So okay. So each factor is 1, right? Each factor is 1. If the exponents are wrong, right, take away half a mark. So 1, 2, 3, 4, 5, 6, 7. Determining A gives you 2 marks. Okay. So no restriction, I would take away 1. You have to have restriction. So this is out of 7. Out of 7. Okay. Okay, so the third question is a really wonky one. We have a function that has no x-intercept, y-intercept at y equals -1, no vertical asymptote, okay, and the horizontal asymptote is y equals -2. Now, let h of x be the function. Okay, so no x-intercept indicates that p of x equals 0. This equation has no real solution. Correct? Similarly, the fact that the graph has no vertical asymptote implies that q of x equals 0. This equation also has no real solution. So what does that mean? What kind of equation would have no real solution? Just take a look at this. So does this have a solution?
Yeah.
X plus 2, yes. Does this have a solution?
No.
Yes, same thing. How about this x minus 2 equals 0? Does this have a solution?
Yeah.
Yes, right? Okay, so how can I make it such that there's no solution?
Square the x.
I can square the x. Let's say if I square the x's. Would this have a solution?
Plus 3.
This has to be plus squared. Is that the only one? Can this be cube?
No,
So cube, well, this one square or cube, it will have a solution, right? This one, can I cube this?
no,
No, right? Can I take ratio to the power of 4 for it to not have a solution? Yes, as long as the exponent of x is even, right? Then there's no solution. So what degree are you going to take for this? Are you going to keep it to 2 or are you going to keep it to 468?
no, you said lowest.
Lowest, right? So, huh? Yeah, I'll just give you that. I'll give you the eye roll. So, no, okay, so take the lowest degree, right? The lowest even number. Same thing here, right? Same thing here. So keep that in your pocket. Now, what about HA? Okay, so what does HA tell us? The degrees, right? Since the HA is y equals -2 and not equal to 0, the degree of P of x must equal the degree of P of x, correct? So h of x, okay, we always have an unknown leading coefficient that you have to determine. And we already specified that we're going to keep this to be the smallest even number, positive even number, plus b plus c. Okay? That in its most simplistic form. So now you have to determine the values of A, B, and C. Okay, so what can help us determine the value of A? The HA, right? The HA. So since the HA is y equals -2, right? The limit of A times x squared plus b over x squared plus c as x approaches infinity equals 2, right? So I can use the same strategy that I've used in the last two questions, that is to common factor out the highest degree in each factor, right? So in this case is x squared, I get 1 plus b over x squared over x squared 1 plus c over x squared equals -2. So x squared cancels out x squared. Right? So I can do direct substitution, quote unquote. Then you have to drop the limit notation, right? So this becomes, the left-hand side becomes a times 1 plus 0 over 1 plus 0, again, in the denominator equals -2. So what does that tell us? A equals -2. So we have the value of A, right? So we used up the horizontal asymptote. We haven't used the vertical, the y-intercept yet. Now it's time to use the y-intercept. Since, we use h of x, right? Since h of 0, right? The y-intercept, that is what it means, right? Equals -1, right? From here. As a 0 equals, so now we just put in what we know, right? -2 times 0 plus b over 0 plus c, right? Equals -1. And here's the equation. So I have -2 b over c equals -1. So 2b equals c. We have two unknowns. We only have one equation. So do we have a unique value of b and a unique value of c? you have infinite number of you have infinite number of BC pairs, right? So this is like, now, what are you going to choose? You're going to choose the lowest, the most, the cleanest number. Let B be 1. So what would C be? C would be 2. Okay. Thus, I have a function h of x which equals -2 x squared plus 1 over x squared plus 2. Any restriction? No restriction, right? Because x can be any value. And the denominator will always be defined, right? As required. As an alternate, if you know this, so this is complete. Think of this 1 over x squared plus 1. What does this graph look like? I think I talked about this, right? It's like a little hill, right? It's like a little speed bump, right? This looks like this. It has a horizontal asymptote of y equals 0. What is the y-intercept? When x is 0, y is 1, right? 1. Okay, so I can transform this. How many steps below to get an x-intercept, a y-intercept of -1? 2 steps, right? 1, 2. Will I have a horizontal asymptote y equals -2? This one, the y-intercept is y equals 0, right? If I subtract 2 at every single point, I'm going to get this graph. This is also okay, but you have to explain it. Okay, it's all about
Wait, so you could write 1 over x squared
-2. So this will also give you that, right? Slightly different, but it's the same. It would satisfy all of that.
So instead of writing,
But no, but then you have to explain it, right? Explain it.
that's
Yeah. So, you know me, it's all about writing essays, right?
essays,
Who's the essay king?
3,000 word poems.
Oh no, 6,000 line poem. Now we have to give marks, right? So this, and this. 5. And then, well, of course, determining A, I'm going to give 1 extra. So it's out of 6. A essentially gives, take up 2 marks. And each one of this is 1. Okay. So it's out of 6.